So we're going to start a new unit on relations and functions. And one of the things we'll need near the end of this unit is to represent a solution that is more than one number. So in this example, x could be anything along this line. Or this one, x is greater than or equal to 3. So x could be any solution in that range. How do we show that mathematically? So a quick overview of inequalities. Always think of it as this is an alligator and it's always going to face the bigger number. 4 is bigger than 3, so it will face that way. If we have 7 and 11, 7 is less than 11. So the inequality will face the bigger number. And in this case, even though 7 is bigger, it's a negative number. So the inequality has to face the positive number. It's bigger. Okay, so now what we're going to do is we're going to take an inequality and try and graph it on the number line. Now we're always going to use x when it's a horizontal representation. So all of these will use the letter x. Now 1 is the boundary point. So I'm going to make a dot at 1. That's the furthest it can go. And I have to look at this. X must be bigger than 1 because the inequality is facing it. Actually, messed that up. X is bigger than 1, so it has to be anything on this side of the number line. 2 is bigger, 3 is bigger, anything along here. Now this includes all the decimals, all the fractions, so we have to have a line to represent every possible value greater than 1. And this little line underneath means equal to. We only put one equal sign just to make it easier. So this is greater than or equal to. It includes the 1. So that's why the dot's there. Try these two on your own. See how it goes. So for this one, the boundary is -3. So I'm going to put my dot there. And x is smaller than -3 or equal to. So smaller than is this direction to the left. I'm going to draw my arrow this way. So this one was greater than, so it went to the right, bigger numbers. This one is smaller than, so it has to go to the left. This one has one difference. 5 is the boundary point, and I have greater than 5. So it's going to point to the right. Now notice there's no equal sign here. So the only way we can show this on the graph is the dot is now white. It's just a circle. It goes up to 5, it gets really close to 5, but it does not touch 5 itself. 5.1, 5.01, but never reaches 5. These ones have an equal sign, so that's why we fill in the dot with black. If it's a shaded dot, there's an equal sign with it. If it's an empty dot, there's no equal sign. This next one, pause the video, try it out yourself, and then check the answer. If we have 2 boundary points, I'm going to make one circle, one dot on each spot. -2, +3. Now there's no equal sign here, so it should be empty. This one has an equal sign, like that. And x is in between these two, so we just draw a line connecting the two. X can be anywhere here. It can be 3, it can be anywhere between the two, but it cannot be -2 because there's no equal sign. So if you can, pause the video, try the next one on your own, and then find the answer. So this one, we go from -infinity, so it's over here going forever, so we don't need a dot on this side. -4, right there. And so it's going that way. So I'm going to draw my arrow going that way. Infinity never has an equal sign. You can never reach infinity, so we never put it in. And this side does have an equal sign. like that. So everything from negative infinity to negative 4. Draw an arrow pointing that way. This is kind of a more formal way to do it. This is just this mathematical saying. The x vertical line bar, x is x such that x. That's all it's saying. The E looking symbol means it's an element. So x is an element of all real numbers. Now a lot of times you'll see R with a second line in the middle. So it's all real numbers from negative infinity to positive infinity. It never stops. So negative infinity to positive infinity. There's no dots at all because there's no boundary points. We never have an equal sign with infinity. Next up, we have this one. Notice that there's commas in between. There's no x in the middle. There's no inequalities. The answer is negative 4, 0, and 3. This is list notation. Only these numbers, x can only be these numbers. So we're going to make a dot at these 3 values. And that's it. There's no line because it's not all real numbers. It's not in between. It's just these 3 answers. So x could be any one of those 3. And this last one is a trick. It's like this one. X is an element of, W. W stands for whole numbers. So think about it for a second. What are whole numbers? 0, 1, 2, and it just continues. There's no fractions, no decimals, no negatives even. So that means even though we start at negative 3, it's not a whole number, so we go to the next one. Negative 2, negative 0 is the first whole number in this sequence. Even though x is in between these 2 boundary points, we're only plotting whole numbers. So 1 is a point, and it stops at 1, so that's all we have. Kind of a trick question there. Whole numbers only between negative 3 and 1. So this next part is we're going in the opposite direction. We're looking at a graph, we see the boundary points and it goes to infinity, and we have to write set notation. Now set notation is when there's a line going through the number line. There's no dots, it's just a line. So we can see that negative 5 is the lowest point, infinity is the highest point. So we're going to go from negative 5 to infinity, and x must be somewhere in between those 2 boundary points. Now, how do we show it with set notation? We need inequalities, and we need to face the bigger number. So they both face the same direction. They're both facing infinity. It's the bigger number of the 2. So x is between negative 5 and infinity. The last thing we have to check is our equal sign. We look for black dots, which we have a shaded one here. So we need an equal sign underneath this. We never put an equal sign with infinity. So that's all it is, smallest to biggest, x is in the middle. So this one, we go from negative infinity to 0. So smallest to biggest, x is somewhere in the middle of these 2. And 0 is bigger, so my inequalities face that way. Now, is there any shaded dots? No. No equal sign on either inequality. Pause the video. Try the next 2 on your own, see how you do, and then start. So this one has 2 boundary points, negative 3 and 4. So I'm going to put those smallest to biggest, x in the middle, and then it's always facing the bigger number, like that. And the last thing is we've got a black dot here. So an equal sign on the -3. And this one kind of has a trick to it. There's a dot on it, but the line continues in both directions. The smallest value is -infinity. The biggest one is +infinity. We don't even list the two because it's not the boundary point. It's just a point in the middle. So x is in the middle. The inequality is facing that way. As always, no equal sign with either infinity. And the last one is list notation. There's no line on this, so we only have these 4 values. There's no inequality needed. So this one, just going to use brackets and list with commas all the possible options. This one, I've got 4 options again. It's -5. And that's it. This is list notation when there's no line in between. Set notation is where we have a line and it's all real numbers in between our boundary points. That's it. So what I want you to do now, turn the page, and this is your practice. Try out all these questions. For the top ones, write set or list notation for each number line. And down here, you've been given the set or list notation, and you have to show it on the graph using a line or dots. Finish all the way down to the end of the page, and that's it for this lesson.